Cool. Yeah, so my name is Chris Baines. I'm an engineer on the Android Developer Relations team at Google. Specifically, I work in Sydney. So I'm here today to talk to you about Santa Tracker, which is the app we've all been talking about today. Specifically, us moving towards Android App Bundle. Now, for those that don't know what Santa Tracker is, it's an app that we release every year, well, Google releases every year, that allows users to track Santa across the world, primarily on Christmas Eve. It's largely engineered in APAC. Last year it was mostly done in Sydney, but previous years it's done in Tokyo. But yeah, it's mostly an APAC kind of engineering feat. We released both a web app, which Sam's going to talk about in a bit, and also an Android app, which I'm talking about. And both of them contain a number of games, but also a tracker. So that the tracker allows the user to actually track Santa. So the app itself is split into three kind of main chunks. The first bit is the main app, which is just a UI, it's a grid of games basically. Then we have the tracker itself. That opens up on Christmas Eve, and as you can see in the middle, you can actually just watch Santa on a map as he travels across time and space. And the third bit is we have 17 games. And these games open up on whenever we release the app, which tends to be about the 1st of December. And they allow sort of users to enjoy the app before Christmas, basically. This year we also added some new stuff to the Android app. So we have a Wear app, so you can actually look at like a Santa watch face on your Wear device, if you still have one. And also stickers. So if you're using Gboard on Android, you'll get this new Santa Tracker sticker pack. Lots of little Santa stickers you can send to your friends. To give you a little bit of history of what Santa Tracker's, well, the history of it really. So this was the first incarnation of Santa Tracker. It was a layer in the Google Earth app, if you can remember this on Windows, and it allowed you to watch Santa as he goes across the world. This year we actually went back to its roots a little bit, in that we added Santa into the location sharing pane in Google Maps. So you can actually watch. You didn't have to have the Santa Tracker app installed. If you have Maps on your phone, which I'm sure most people do, you can actually go to the location sharing pane and then you'll see him travel across the world instead in that app. So every year we try and set some goals for the app. Now we start development in around October time. This year we're actually starting a little bit earlier, well, Sam is, in about September, but it tends to be a quite short-lived project. It's basically 2 months of engineering and then two weeks or 3 weeks trying to get it released out the door. But there's always some kind of product stuff we want to actually get out there. So this year, well last year, sorry, it was the sticker pack. Now there's also development stuff we want to do as well. So we release the source code to Santa Tracker every year. And so we want it to be both a sample and also a product at the same time, and those two usually conflict. Now our goal for last year was to reduce the size of the app. The size of the app in 2017 was 60 megabytes, which is pretty huge for an app which is only used for 3 weeks. And the main reason why it was so big is because we added a Unity game that year, and Unity is just huge. But yeah, that was the reason why it's called blew up in size to 60 megabytes. And so our real goal for last year was to bring that down to 10 megabytes. And that brings into Android App Bundle. So this was something we kind of announced, what Google announced in I/O 2018, so about 18 months ago now, which is our new format for publishing Android apps. Previously, you'd ship an APK, which will be the artifact that you ship to the Play Store, and that artifact is what gets sent to users. With Android App Bundle, we're kind of breaking that chain in that what you provide to the Play Store isn't exactly what users get. It allows the Play Store to dynamically optimize your app for you, and it can serve what it thinks is correct for the device. Whereas before, what you give the Play Store is exactly what, bit for bit, what gets set down to the device. So yeah, one of the things they say is that it'll bring your size down by 35%. I wouldn't believe that so much, but on average, you will save data. So it does work. So the primary way it works, and the way it saves data, is that it only delivers what is correct for the device. The way it does that is via what we call configuration splits. So what you do is when you upload an app bundle to the Play Store, you're actually delivering, instead of one APK, it's actually about 25 APKs. What happens internally when you build that is that it will split all of the different things up and then just zip them all together. The splits are based on your languages, so you can imagine that most apps will have a lot of languages in there, English, French, whatever it is. Now for most users, they're going to use primarily one language, so you can think that all those other languages are just a waste of space. So that's where one place we can save space density, density drawable. So when you create ping resource in your app, those are specific for specific devices. If your device is XX HDPI, there's no point downloading all the MDPI assets as well. And similarly for native architecture, so if you've got native libraries, so Unity was the prime example we had, you will tend to build multiple versions of that. So ARM 64-bit, ARM v8, ARM v7, whatever else. Now, each device will have a specific version. There's no point the device downloading all of them when it only needs one of them. So that's what it does. It's all about slicing the APK, and so it only downloads what it needs. So given a bundle, this is what the Play Store does. So when you build your bundle, it'll build what we call a base APK, and that will contain basically your Java files, your manifest, basically anything that's common to everything. Then it will split out your resources, firstly on its density, and then if you've got any native libraries, it will split those out, and then thirdly, it will split out any language-specific resources, your strings. Now you may think strings don't actually take that much space up, but actually they really do. They can grow quite large. So we look at Santa. Santa's got a Samsung Galaxy J5. And that device so what will happen when he presses install on the Santa Tracker app? It will download the base APK, it will download the XHDPI resources, the ARM stuff, and then the English, because he speaks English. Mrs. Claus, on the other hand, has a Pixel. And she can speak both English and French. So instead, slightly different this time, different resources density, but we also download the French and the English APK. Now, if she also dynamically, after the app is installed, changes her languages and she adds Portuguese for whatever reason, what will happen is the Play Store will automatically download the new Portuguese APK and then reload the app. So it's dynamic, it happens automatically for the Play Store, so it's quite cool. So what we just spoke about is kind of Lollipop and above, because it relies on a feature called split APKs. For pre-Lollipop devices, if anyone still cares about those, it's a little bit different. Because we don't have split APKs, what the Play Store will do is it will basically create a massive matrix of APKs for you for the kind of combinations that it can support. Because we don't have split APKs and we can't do that dynamic language stuff, it just includes all the languages. So just to make sure that all the languages on the device are supported. So some of the cool stuff App Bundles enables actually isn't to do with App Bundles. So a feature that was added to the platform in Android Marshmallow, so this was like 5-6 years ago, is a feature called uncompressed native libraries. So if you have some native libraries, say Unity or something else, you'll have a native SO in your APK. Now prior to Marshmallow, what would happen is when you install that APK, because it can't access the SO directly from the APK, it would basically unzip it and take it straight out. What that means is that you've got a copy in the APK and you've got a copy unzipped in your data directory. So that native library is now taking 2 times the space on the user's directory, and for most users, they don't care, and you're just wasting space. In Marshmallow, what happened is we added this feature, and what it means is when the APK is built, the SO file is put at the end of the APK, and it can be nmapped directly. And what that means is that instead of it having to be unzipped, the system could just reference the native library straight from the APK, and that unzipping doesn't need to happen. Now, that's just a feature in the platform, but you have to do special stuff with the build. Now, because we've broke that link between you building the APK and you loading the app bundle, the Play Store can do this all for you. You don't even have to think about it. It's just an optimization which the platform gives you, but the Play Store does for you automatically. It's just kind of cool. If you had to do this yourself, it would take you ages because you have to generate about 30 or 40 APKs. So yeah, it's just good stuff that the Play Store does for you. And that's just a graphic showing what I've just talked about. Yeah, some rough numbers they gave. It tends to be, those numbers are pretty rough. It depends on how big the native libraries are in your APK. For Unity, it tends to be about 30 megabytes, so you can imagine that duplicated isn't great. And so back to Santa and us using Android App Bundle. So us just shipping an app bundle instead of an APK instantly saves us, about 13 megabytes. So we saved literally 20% of our APK size just by uploading that bundle. And it took us about, 2 hours or so. So it's actually, if you want to try something, and you have an app, and you want to try saving some space, just create a bundle and upload that instead and try it out. So we got to whatever it was, 80% of our app size, but we want to get down to 10 megabytes. So the next part we do was feature modules. And so feature modules are a new thing in the Play Store that allow you to split your APK up, your app, into sort of separate cohesive chunks. Now we have an obvious place where we can split our app up, and that is our games. We have 17 games, and the user is not going to play all of them at once. So there's no point shipping them all down straight away when the user installs the app. We can do it dynamically. So we kept the important stuff like the UI, the main UI, and the tracker, because they're like core to the app in the main first install. But the rest of it we kind of deferred, and we put them into a feature module instead. So the way you do this, so you split your you have to do something called modularization. So you split up your app into discrete chunks. And then in your manifest, you use this piece of code. So you have to tell the kind of build tool that you want it to be a separate module, and you give it a title. So the title in this instance is the Elf Jetpack game, which you may have played. But yeah, we give it the title of Elf Jetpack. And the last bit we need to do is tell it to be on demand. And what that means is that it won't be in the first install. So when the user presses install in Play Store, it won't actually come down the first kind of payload. It's deferred. Some chunks in there. So the way you'd split your app is that you'd have a base module, and then you'd have all these games on top of it. So we're going to depend on our base APK. You can look at the slice layer for more code, but yeah. And then you need to link the two together. So you have your app. You need to tell it what the feature modules are. So here we have one called the Elf Jetpack. Actually, the list is about 17. So yeah, we have about 17 games which are feature modules. So now that we've created our sort of on-demand modules, we need to actually tell the Play Store to download them for us and then actually restart them. So the way we do that is with the Play Core library, which is a new thing we shipped last year. So this is what it looks like in the Santa Tracker app. So when it refreshes, so the users just click the game. In the background, we're telling the Play Core library to download the module. It's downloading. Play Store's telling us the progress. The Play library tells us it's downloaded, and then we start the game. So it happens pretty seamlessly. It's, you wouldn't even know that this is downloaded in the background. Yeah, it's pretty cool. So what was actually hard? All of the game modules were pretty coupled together. As most app to grow in size, our code base was pretty horrible. And it still is, to be honest with you. But we've managed to get it into a state where all the games are separate chunks, which allows this stuff. Yes, we had to spend a lot of time splitting them apart. The other thing is that testing is quite difficult. To actually test all this stuff, you've got to basically do a round trip to Play Store. So you've got to upload the bundle to Play Store, then you've got to wait for it to download, and then you've got to test it. So you can't do it locally, which is a bit of a pain. The best way we found of doing it is the internal test track. So that's a thing on the Play Store where you can upload an app, a bundle or an APK, doesn't matter what it is. But you no longer have to wait for the Play Store to process the bundle or the APK for it to download. So if you're using the alpha, beta, or even production tracks, when you upload your bundle or your APK, there tends to be a 2 to 3 hour wait for that to process and be available for users. With the internal test track, there is no wait, it's about 5 minutes or so. But it's only really meant for quick iterative development. It's not meant for shipping it to users, really. So in terms of results, we managed to get our Santa Tracker app down to 9.21 megabytes, which is pretty good. And in total, this is a random stat, but we total saved about 42 terabytes of storage and transfer, which is good for perf. And Mr. Peng was very happy because we saved 85%. So at this point, I've just spent 15 minutes talking about Santa Tracker, so I'm going to give you the option of why it's big right next. So I can have a talk for another 10 minutes or so about app bundles, or I can talk about Android Q and its gesture navigation, which is coming soon. So
gesture navigation.
Switch. I just copied slides from IODex. Where's my mouse for that? Where's my mouse? Cool. So this is a talk I gave recently in DroidCon Berlin, so I'm going to go through it quickly. Well, I'll skip bits which aren't that applicable. So as a quick refresher, if you don't know what it looks like, in Android Q we have a new gesture navigation system. So hopefully they're playing. Yeah, there we go. So To go back, you now swipe from one of the edges. To go home, you can swipe from the bottom. So you can see examples of it working in action. So what kind of nav will happen in the future? So you may be kind of afraid that we're going to get rid of the free button nav, like the navigation mode, which has been available for, I don't know what it is, 5-6 years. Now, free button mode is going to be required for all devices going forward, so we're not getting rid of it. And the primary reason for this is that it's great for accessibility. You know, gestures aren't very good for people who haven't got impaired vision or impaired movement in their hands, and therefore, you know, we need to keep free button mode for accessibility reasons. Gesture nav is going to be offered as sort of the experience for gesture navigation going forward. So if any device ships a gesture navigation, so there are various OEMs which have one now, like Samsung, whoever else, they have to also support as well. So why is it important for apps? So there are two reasons for this, actually. So the first one is that it gives you an increased immersive experience. So it gives you basically more of the screen to actually play around with. The other is that on the usability front, we want to ensure that apps effectively handle navigation going forward. I'll quickly skip this bit. So there are three things for your app to be what we call nav ready. So that's to be able to handle all the different navigation modes that we support in Android. There's first to make your UI go edge to edge, which I'll talk about in a minute, then handle some of the visual conflicts, and then handle the gestures itself. So what is edge to edge? So this is what your typical app looks like on Android today. Now in terms of bounds and what you actually get to play around the screen, it's this. So you're below the status bar and above the navigation bar at the bottom. Now what we want going forward on Android Q is for apps to do this, where the navigation bar goes away and your content displays behind the navigation bar. And then when the user scrolls, they get this, where the content actually scrolls behind the bar. As we said, it's trying to create that immersive experience. At the top, we want something similar, where we want the status bar to kind of disappear as well. The difference here is that it's only applicable for some types of content. So if you've got things like this, which is kind of big imagery at the top of your screen, it will tend to make sense. But if you've just got a list of items, probably won't make sense too much. To have those items scroll behind the status bar isn't that immersive. But yeah, this is a judgment call on apps. So yeah, drawing behind the status bar is kind of recommended on Q, but it depends on the content you have. So edge to edge, which is a moniker we've kind of created over the past 6 months or so, means going from this to this. So how do you actually go to edge? So the first thing to know is that the system will help you going forward. So as the user scrolls, that navigation bar handle, what we call, will actually change colour based on the content behind it. So you can see on light background it goes dark, and on dark background it goes light. And that's because the system, going forward, the system is responsible for all of the background protection for the navigation bar. So protection can be in the form of colour adaptation, which you've just seen there, or it can also be in the form of a scrim, so a transparent kind of overlay to protect the background content, which you can see there at the bottom. So going forward, we want apps to kind of, this term we've used too much, but immersive, to create that immersive experience. And there's 3 kind of steps towards that. The first is changing your system bar colours. So because we want content to be displayed behind the navigation bar, you need to tell the system that you're happy for that, to do that. And the way you do that is you need to tell the system that you want the navigation bar colour to be transparent, which is done by this piece of code. That's on Q, but you can also support it prior to Q as well. It's totally optional, but the code you use to do that is pretty much the same as what you need to do on Q. Therefore, it's up to you whether you put the extra work in or not. It's not that much extra work, but you can. The difference that you need to do is that because on Q the system is responsible for that background protection, prior to Q it's not. It just lets you do it how you want. So therefore, you need to do it yourself. This is the summary. The easiest way to do that is just a translucent navigation bar colour. You can set yourself. If you have a light theme, this will be like a translucent white. If you've got a dark theme, a translucent black instead. The next thing you need to do is you need to tell the system that you actually want to be laid out behind those bars, what we call full screen. You do that using the system UI visibility method, which is one of the most horrible APIs in the world. It's an int-based flag with about 20 flags in there. The two you really care about for this particular kind of scenario are these two flags. The one at the top is most important. It tells you that, well, it tells the system that you want it to be laid out as if the navigation bar wasn't there, which is behind the navigation bar. If you also want to be laid out behind the status bar, there's also this flag. So the third and kind of final thing to think about is insets. So when you go edge to edge, it means that you are going to be displayed behind the navigation bar and the status bar at the top. But you can imagine there's actually content in those bars. And so you've got the navigation bar handle at the bottom, and then you also have the clock and notification icons at the top. And what it means is that you may have views that sit behind those, so you want to move them out of the way so they're not going to be obscured and the user can actually click them or whatever. And that's where insets come into play. Insets are basically rectangles that the system tells you where the system UI, so the navigation bars, are actually displayed over your app. So which content to kind of move and how to move it depends on the inset type. I'll quickly go through the inset types now because there's 5 of them now. The first one is what we call the system window insets. Now these have been available since API 1 in various forms, but they tell you where the system UI, so the navigation, the bars, are displayed over your app. So here you can see that the green at the top and the bottom are where the insets will tell you. The system window insets, those will contain those values. We should really be using them to move clickable views out of the way. So you can see a floating action button at the bottom, and you typically adds a margin of about 16 dips on it, which you can see the little bars. Now because it's actually behind the navigation bar at the bottom, it's not great, the user may not be able to click it. So what we should do, we should use the insets to just increase the margin. That's basically what you do. It's more obvious when you have button navigation mode instead because the button nav bar is bigger. So here instead we get this instead. So on gesture nav it's not so obvious, but on button mode it is much more obvious. The next inset type is called system gesture insets. These are new in Q. And now these represent the areas of the window where the new system gestures take priority over your touch handling. So it's quite a controversial topic. So visually they look a bit like this. So you can imagine that where the system gestures actually are, where they trigger, are in these rectangles. So on the edges, you've got the back gesture. So that's the system taking priority over your touch handling on the left-hand side. The same thing happens on the right. So if you're swiping from the right, it's also a back arrow. And then also on the bottom, same thing, but this time for the home gesture. You can see that the actual area is larger than the back gesture, so it takes up more space. The third, fourth, whatever type it is, we have are called mandatory system window inset, system gesture insets. Whoever named these really badly. These are a subset of the gesture insets I just spoke about, but these define areas which cannot be overridden by apps. Now I've kind of jumped ahead a little bit there where I've said you can override sort of the areas. We'll talk about that in a minute. But what this means is that these are the areas which you cannot override yourself. Now on Q, that is only the home gesture, and that is because that home gesture from the bottom of the screen is protected. An app can never interfere with that. It's always available for the user, and that's so apps can never trap users into their apps. So as a quick summary, system window insets are for clickable views and moving them out of the way, that floating action button you saw. System gesture insets are to move draggable views away from the edge. So you can think of bottom sheets, carousels, that kind of view pages, that kind of stuff. And then mandatory system gesture insets, you won't typically need to know using them themselves, but it's good to know that they're there and they tell you where the actual protected zones are. So how do you actually handle these insets? We have an API which strikes fear into many developers called the Window Insets API. As a quick summary of how you actually use it, there's various ways to use it, but this is the opinionated way to do that. We have an API called Set on Apply Window Insets Listener in Android X. And so the easiest way is to set that on the view, and then you'll get your insets passed to you. Use those to do what you need. Increase padding or margin, whatever you need to do. The instance passed to you has 4 main methods on it. We'll talk about the first 3 really, because I'll skip the 4th one. But get system window insets, system gesture insets and mandatory system gesture insets, which, as you can imagine, apply to the inset types I just spoke about. They each return a type of inset, and that is, for all intents and purposes, a rectangle. It has a left, a top, a right, and a bottom. And that just tells you in pixels where the system is, whatever the inset is trying to tell you, that's what it tells you in pixels. So skipping back a little bit to what I just talked about with gestures, and we'll go back to kind of overriding them and how apps can actually interact with them. So swiping in from edges will go back and reactivate the system gestures when you're in immersive mode. I'm completely over here, but you can see here an example with a photo cropper. So you can imagine that those crop handles, the left, top, right, and the bottom of the image, are quite important. But you can see that they're probably going to conflict with the back gesture of where they are. So you can see here. So wouldn't it be great if we could tell the system these photo croppers, the crop handles, are more important than the back gesture, leave them alone. And then we can do that. I'll skip it a little bit. So yeah, we can do this. So we can basically tell the system, this rectangle where the photo edges are, ignore them. If the back gesture starts being triggered here, just ignore it. Let the system handle it. Let the app handle it and do its cropping as what it needs. The API we have for that is this method here called set system gesture exclusion rectangles, which is a great API. And you just give it a list of rectangles. So you can imagine the photo example, it will be the top left, top right, bottom, blah, blah, blah. The way you set that is either in your on layout of your view or in your on draw. So you can imagine if you have a game, or even the photo example there, where you have a view which is drawing something dynamically, doing it on draw is probably better. Coming soon, we have some new restrictions on this API. Previously, when we launched this at I/O, an app could exclude the whole edge, which wasn't so great because there are a few examples of apps using it in a way they shouldn't have, and users could never go back from that app. Going forward, we have exclusion. We have a limit on that API. So from now on, you can now only exclude 200 dips of each edge using that API, and that's a new limit that's going to happen in Android Q going forward. It hasn't quite launched yet, but it will be very soon. So here you can see that the app has requested all of those rectangles, but the system only honors the bottom 200 dips, which is the green area. Which basically means that if the user starts dragging in that blue area, it will actually go back. The system doesn't actually honor that exclusion. So I thought it'd be quick to go through some, as I imagine you're all hungry right now, some common scenarios. The first scenario is scrolling views. And so here you can see an example of a list. And as it scrolls, you can see that even though we're drawn behind that navigation bar at the bottom, at the very when the list is at the very bottom, you can still see those bottom items. And that is because we've added some padding to the list to actually push it up from the bottom. So yeah, you can see the example here. So the way we do that is via the set and apply window inset system API we spoke about earlier. Once we've got those insets, we just update the padding at the bottom of that. One thing to note here is that we need to use the clipped padding attribute on the view. By default, views will clip any content of its views to its padding. And because we actually don't want that, we want the content to be displayed in the padding, we need to turn it off. It's an optimization, which is good usually, but for our example, not so good. Bottom sheets, if you don't know, they're that grey thing at the bottom. And so as the user, so if we move the bottom sheet up a little bit, you can see that, video play a little bit, there we go. So users can actually drag them up and down. So these are like movable panes at the bottom of the screen. Now because they're very close to where the home gesture is going to be, we need to do some special treatment to actually just move them up a little bit, so away from that home gesture area, which is what we're talking about there. I'll skip for the code. The slides are all online if you want to have a look for the code. But remember that the user can always go back from the home gesture. So even though we've done some special stuff of moving the padding and moving the view up a little bit, the user can always still actually go home, even though if they just drag slightly the wrong place. Landscape we'll skip, because we'll skip some time because no one cares about landscape. Navigation drawers are probably the most controversial thing with gesture navigation, because navigation drawers are so prevalent in Android apps. We know that this is controversial, and stealing away that gesture zone away from drawers isn't so great. The way we've come up with this is that we've kind of changed the gesture slightly. So instead of the user just being able to drag from the edge, what happens now is that the user will need to press and hold for half a second or so, and then drag. So you can see here in the example, yeah, there we go. It's a small drag and hold. We're hoping that users get used to it. It's going to be a teaching exercise for all of us. There's no good solution to this. We're going to have to add this gestures area to it. And so there was always going to be a conflict. We're taking feedback on, and we're going to learn as app developers do as well. So this is going to be a learning exercise for all of us. For carousels, which for all intents and purposes are view pages, a lot of people going on about can I exclude these things? So you can imagine Play Store. Play Store has these kind of big horizontal lists. Now what we think is that users will actually get used to where to drag. And so the drag areas for back is actually pretty small. It's like 20 dips. And so it may seem like a very, very extreme, but it's actually a pretty small area. And so we think that users actually get used to this pretty quickly. It takes a few days, but it does happen. And so they'll just start to learn where they can drag and where they can't drag. So we really don't want that exclusion API that we spoke about earlier to be something most apps use. It's really a catch. It's to get out of jail free card kind of thing. It's not a primary use. So just a quick TLDR. Again, you can find the slides online if you want to read this. Thank you. That was a whistle-stop tour of Gesture Nav.